Hello, hello, can you hear me? Mm. Hello, now can you hear me? Okay, okay, let's see. What is this about? I need to do something for this. Mm. Wait, it's not good news. Okay, so let me check if my live is okay, perfect. Is there? Let me check his quality. Hello, can you hear me? Hello? Let me check if my live is perfect. Is there? Let me check his quality. Hello, can you hear me? So quality is good, but I guess I need some kind of mic or something. Okay, guys, let me get one more thing here. So we will be quickly get started. It is from, okay, perfect. This is done. So first I will start with short break, and the reason is very simple. Hi guys, for the next 5 minutes, I'm going to talk about a bit before we move into this session. So this session is about AWS data engineering preparation, that is PECA01, that is category 1 AWS data engineer. So in this one we're gonna prepare for the examination in next 30 days. 6 days is already gone. We are aiming that in next 24 days we will be able to get it to a level that we can give our examination and crack it with flying colors. So we have a certification with that because it's pretty expensive. Okay. For this one, what I did every day, I'm going to come here and do live sessions so that I can record what I am learning, and meanwhile you can also learn alongside with me. Perfect. So for this one, I am using your YouTube as a medium of communication or a medium to store the things. Here you will find subscription button. Make sure that you subscribe it because this is something that gives us the power to keep on going. Perfect. So the second thing that you have to do after coming here is to subscribe or follow my LinkedIn account. Reason is whatever I learn, I create small, short, uh, fact figures or very interesting question that I constantly upload where on the your LinkedIn. So this is something you won't be able to find in YouTube. So you have to go to the LinkedIn. Plus, I also constantly upload articles about what I learn. So to read those articles in due time or to get the notification, you have to follow me on LinkedIn. Third and very important is GitHub. Simply go there. If you click here, you simply go here. Repository is SQLs. If you go here, you will find the number 4 directory, that is 0 to hero. And this is where every day what I am learning, I am keeping it tab here. Like I'm creating a corresponding MB file or a HTML based file, a markdown file. So you can simply start from 1, 2, 3, 4, 5, 6, 7, 8, and go forward with that. The second one is a roadmap that we are constantly following to keep our learning constant. Okay, so I made a mistake. So we don't have to go because right now it is AWS. Because after this session, I'm going to start learning Postgres as well. So if you are interested, you can simply join there. So you need to go to AWS. Here is the syllabus, and this is something we are following at the moment. So thing is, our main course that we need to go through to prepare for to have a solid preparation for our exam, we need to do a prerequisite course that is called data engineering on AWS. Okay, that's something we need to do it, and currently we are doing it. It is divided into 5 sessions or 5 particular sections. First one is foundation, that talk about the term and terminologies. For example, what is data engineering? Well, what is AWS? What's the correlation between them? What's the services AWS provide? Is the burden of data engineer. Second, the two major things that data engineer perform, that is storage and then the processing. Data storage and data processing, that is the core foundation of a data engineer or data engineering. As we're gonna learn in the next second, third, fourth, and fifth section. So here in the storage, we're going to learn two major storage, that is data lake and data warehouse. And this is something I have covered in the last 3 days constantly, but we're going to do it again because I will tell you the reason. Second one is data processing. So two major things that data engineer perform in the all the activity that are their data storage. And second one is data processing. This is batch, and second one is stream. Okay, so right now we are in this one, and currently today or tomorrow we will be able to finish this one, and then we will simply move to second, third, and simultaneously, or then in sequentially we will go to fourth and fifth. Perfect. So that's we are performing. After this is done, then we'll quickly go back to the remaining part of the actual course. This we need to do it before we go and give our examination. My current aim was 30 days. Today is 6 days completed, and today the date is uh, 18th 18th March 2026. Next 24 days, like around mid of April, I will give the examination, get the certification, and that's to improve my resume. So that's all about this one. Let's get this started. So let's start the 25 minutes of a study. Okay, so let's quickly give me a break. So what my study plan is. So we're gonna divide our study plan into 3 sections where it's gonna be 25 minutes each, and in between every 25 is gonna be 5 minutes break. Okay. First one is all about revision. We always do revision. Second and third is all about learning. Okay. So revision for this course we're gonna start. So let's quickly go to here. So here, if you consider data engineering on AWS learning plan, that's the prerequisite course we need to do. And you see it, the first one is foundation, second one is data lake, third is data warehouse, that's data storage. Now the remaining two section gonna talk about processing, so batch processing and your stream processing. So let's go to the foundation. Okay, so in the foundation, there are majorly 3 things that we need to learn as part of the process. Since I'm not going much into this one because this is something we are doing for the last 3 days. So if I have to block this out for better understanding, so the first block is here, second block is here, and third block is here. So what the foundation lays, it tells you the overall organizational process what happened in data engineering. The first thing that happened is called data discovery. Okay, that is called data discovery. Second thing is actual data engineering, and third thing is data consumption. Okay, so data discovery lead to foundation of data engineering and data consumption. How? So in data discovery, it follows 5 or 6 steps. The very first step is business value. I will tell you what is it in a short brief. Then it follows is the end user. The third thing it follow is data source identification, and then data storage, data processing that involve data ingestion and data actual processing. Okay, and once that is done, we will move to data engineering part based on the things that is gathered here. We will do perform this one, and then once this is done, then we will move to data consumption again. Based on this one, we will develop this one. Okay, so what is your business value? Okay, so thing is, if you go as the owner of a data and tell a business that you want to do something with data, do you think anyone allow you to do it? Answer is completely no. What gonna happen? They will ask you what you gonna perform and what benefit it will give to the business. Is it going to gonna give another source of income or another source of revenue, or it is going to increase our sales, our profitability, or it is going to decrease our losses or expenditure. So there should be some reward for which they can allow you to perform this particular project. So that is called business value. That is to make your business align with your vision so that they are ready to invest in your project. Second one is end user. So since you know that what you want to do with the data, you want to understand who is the ultimate people that gonna consume it. For example, is it gonna be data scientists who gonna consume this project to create some prediction model or something, or is gonna be end user who gonna consume this data or use this data or learn about this data through visualization or WBI or any website. Who is gonna be, how they're gonna use, what will be the number, how are you gonna maintain the security? This is something they talk about. So it's like top to bottom approach. So this end is okay. Now to perform something on a data, you need to understand what kind of a data is needed, where it is reside, how we can access it, and what is the frequency of its refresh and all those things. So the third thing that came is data source identification. Once we are clear what kind of a data we want, where is it reside, in what format is it reside, then based on that one you can create your own storage where you can bring the data from multiple sources, say A, B, C, into one single folder or directory so that it is universally available for each and every developer, each and every investor, each and every person in the project. So because to centralize this data, we need to create this data storage that data engineer does. Then to bring the data from that place to our storage, which is called data ingestion, that's a part of data processing that I told you. Then we need to process the data and convert into something that user want to consume, or like data scientists want. For example, you have 10 tables, but data engineer want only the data from 2 tables. That's also by combining and doing certain changes. So that means you need to do changes, you need to perform some computation to bring the data, process it, and make it in the format that data scientist or my end user want, right? So data processing. And whole of this has to be done within a protocol of data security and data governance. Okay. Now, what data engineer does? Who are data engineer? We need to understand first. So, data engineer are the person who convert raw data like this, something unshaped, something like this, into a finished product that can be consumed by end user. Okay, this is the one. It has some value associated with the change you make on the data. Let's give an example. Suppose, mm, okay, so you have the data of a student of a university. Now, what happened? You need to understand that what is the median or the median of the student age, so that when you try to advertise your university, you can create advertisement based around that age group or age range, right? For this one, what you want all the student data, their corresponding ages when they enroll and when they left the organization, or when they like graduated. And then based on this one, you will create a range, and then based on the range, you will create the median or a median range, something that gives you an understanding of what kind of a range of a student take enrollment into the university. And prior to that 1 year or half a year, you will create that advertisement based on that age range, so that the student of that age range can get attracted to the university. And then you can create one more of the corresponding age group, like based on the parents as well. So you can target it. So this target become completely based on the numbers that you receive from your university data. So the data was they get the data about the particular student, but you get a specific data out of it, and then you utilize it as a base to create advertisement to focus on that age group of a student attract to your university, right? So this conversion of the data that was present into something that can be useful into an application, this is something transformation is done by data engineer. Okay. So in the data engineering process, two major things he does. Two major, like he will do multiple things, but the core gonna be two things that he has to have. skill set or certification or experience. First one is data storage. Data storage. He need to be very storage where he can design, develop, and maintain a data storage for a corresponding data set that gonna reside in that particular data storage. Second one is data processing. We should be able to code, he should be able to use different tools or softwares that can read the data, access the data, read the data, process it, and get the actual output to a particular place there where the user want and consumption, or it should be the input to another program or another software. So this is the core of a data engineer, where he need to have expertise, he need to have an experience, he need to have projects, or certification is an add-on. Okay, that's the reason we are doing AWS data engineering course, where AWS as a web service provider provide the tools, softwares, or services, web-based services that enables you to perform this data engineering task. And that's why we are called AWS data engineers. Okay. So what are the steps that data engineers have to perform? As I told you, the first one is ingest the data. That means to data ingestion is to bring the data from different sources to us to a folder or a place where you and your team can access it at any given point of time. What is the reason? Reason is if you simply go to their places. Suppose one is a store in database in America, second is a store in a computer file system in Europe. And what happened? You can go and access this one and you can run your program. That's good. But what happened if there is a dependency between these two? How are you gonna do that one? That means you need to bring a data into a place that is common. And once both file from this and this is available, then only you can use the logic that bind this together in a same place. So to increase high accessibility at the same place, we need to get all the data in the same place. Okay. So it increase accessibility, visibility, and understanding. And secondly, also enables you that you can put as much as power, you can increase the computation power, reduce the computation power based on the data you receive here. That's something you cannot simply go and do it in the platform that is owned by someone else, right? They can give you the data, but they won't allow you to do any change in this one. Suppose you got the access, right? You ask them that we want to create some dummy table so that we can use it in intermediate processing. But what happened, you simply dropped all the data set or all the data warehouse or the database. Dude, because you need access as a author or as a writer, right? And you simply fire the wrong query by some intern or someone intentionally or unintentionally, and you wipe out everything. So to avoid this kind of a thing, they are like, we won't allow you the access, but we can give you the data. And then you can bring the data in a same place, and then you can provide the software with high level of computation and the settings, and then you can process it. So that is data ingestion. So, as I told you that to bring the data from different sources, okay, input sources to our actual repository or our centralized repository. So that means you need a data storage where you're gonna store everything. But the problem is the data, as I told you, this is the file system, so it can be TXT file, MP file, anything. This is your file that's stored in the database. It can be Parquet file, ORC file, or Excel file, anything, right? But here you need something that can store any format of the file or data, be it Excel file, be it CSV file, be it your Parquet file, or ORC file, or it can be any of the file, text file, anything. So this kind of a storage that allow you any kind of object or data files to be ingested or stored, this is called data lake. So we will use AWS data lake, that is called S3 simple storage service. The third thing that we do after this is to get metadata and logged in catalog. See, if somebody is dropping the file in a data lake without any prior check or structure, that means Somebody can drop it anytime. But how will you know who dropped it, when they dropped it, what's the name of the file, where it is dropped it? You need to search it everywhere. Suppose you created one, because it's a file system, right? It's the same as file system that's a Linux system kind of a thing. Okay, you have to search it manually. That's not the right thing, right? It become a swamp. Like everything is dumping or garbage dump, right? Dumping. You don't know who is dumping, where is dumping. But if you organize a segregate based on the area, then based on the colony, based on the floors, then it become easier. Because how you do it, you simply know in a chart sheet that for the landmark A, for the area C, for the colony number 8, for the building number 2, for the floor of this is the location where this is stopped, and this is stopped by this is the location x and y axis, longitude and altitude. Now it become easier to access that particular garbage that somebody's through that, right? Based on this information. And that's something that happens in data lake. Avoid it become a data swamp. We have a place where all the information about the files that is either dropped or updated is being held, that is called Glue catalog. And one who update this is a software that constantly run, that is called AWS crawler. Now we were able to create a storage. We bought the files when we create the catalog. So now we know bit about initial information of the file. Now we can process the file. So data processing. Once data processing is done, what you have to do, you need to send this data to the end user or consumer user who's going to consume. For example, data scientists might consume it to run their model or to train their model, or you can send it to a Power BI dashboard to a data analyst who gonna showcase this as a presentation to highest stakeholder, or you can send it again to a Tableau dashboard to the end user to visualize the data and understand what's the track and what's the story. So this is called data delivery. And when you do all this thing, it has to be done under the strict watch of rule and regulation. That is called data security and data governance. Data governance is like is a set of rules that we need to follow and ensure a streamlined process of data flow. So we are done on this, right? So now we understood this one, but how we implement it. So one you can do, you can simply take one big py file and start writing everything, but that's not feasible. First, second is hard to understand, and if something is failed, you cannot detect it, and it's not feasible for scalability. What you did, instead of writing a big file, you divided the file into multiple modules: file 1, file 2, file 3, and so on. Each file is for one module, that is say like data ingestion, data storage in case you need to transfer the data from data lake to a specific data storage like database, data warehouse, NoSQL database, or a file system or EMR, anything. Okay, for that one, this is then data processing and then data delivery. Okay, so each step you created one file that perform a particular task like modularity, right? Model, and then you can simply run them one by one. One you run, a second you run, a third you run, a fourth you run, and your data is done. So it is able to move from the data source to your system to process the data, and then it will load to the place where user want under the strict guidance of data security and data governance. That's the baseline, right? But if you listen carefully, what happened? This model you are running manually. Is it possible to automate this more? Right? I don't want to run it manually. Then it come a scheduler. You can schedule it each and every this one, like 12 o'clock, then 12:30, 4:30, 5:30. But you know that this should not execute before this one, right? There's a sequential order. That means if you run it 12, you were like, okay, in past couple of time that I was watching it, and based on the data, I can give a buffer of 1 hour, make it 13, then 14 and 15. It was running fine for a couple of months, but later what happened? Data increase or surge very drastically, and instead of 1 hour, it started taking 3 hours. But the problem is like your this job started running just after 1 hour. Okay, right? So when it was running at the first hour, it start executing and it is still in the run state and it start executing. That means it should be a fail state. So now the need was optimize this process. That means we need something that is able to communicate And once this job is done, then it automatically triggers this job. When this is done, it automatically triggers this up. When this is done, it's automatically trigger this one. And this happen automatically. We don't need to indulge. So this kind of mechanism where one module talk with the another module based on a sequential or a logical order, this is done by technology called orchestration. And we have different software for this one, that is AWS workflow, and I think AWS Step Function. And then from Apache, we have Airflow that I'm going to learn, and these two as well. Perfect. So this is something done by Apache Airflow. So this is the prime example of automation, something that we can replace with program, automate the thing so that human intervention can be reduced to minimum or none to zero. Okay, so that's something we learned in our previous one. So let's quickly go. That means how much we cover. Introduction done, data discovery is done, data architecture completed, orchestration is done. Now, you see orchestration, right? We have done this one. See automation, all this one. Okay, zero ETL. This is something I want to tell you about. So you remember what I told you that we need to bring the file from this system to our this one so that we don't use their resources to execute in case if they're not able to handle our processes or they are not good enough or they don't have the software that we need to process this, right? So we need to bring it. But if all this data set is in AWS and AWS are all the services, so instead of bringing the data into my data lake and then processing it, or then to put into a corresponding storage and then processing it, what we can do, we can simply go here and we can come with our services and our own infrastructure and start executing directly on this data set. Once we get the data from multiple places, then on the fly go, we can simply merge them and then we can simply load it to the final output or output user and end consumer. So now in between what we were doing that fraction, then we were transforming and then ultimately loading to the end user, right? This is bypassed everything. We simply go to this system, process it, and once we get the data, we simply merge it on the fly and then directly load it to the end user. So we are bypassing extraction and we are just simply transforming on the fly and then loading ETL. So basically we are just abrogating the ETL entire as a process and we simply going for zero ETL where we simply so that extraction and then everything is removed. We simply access the data, process it, and load up this one. This is this is good. This one is really good. I'm not against it. Only the problem is you need to make sure that your entire data sets, all this one is in the cloud, and that is something not feasible at the time because this system become popular in last couple of years or a decade or some. And before that, people are using on-premise system, so it is hard for them to transfer everything in cloud, especially when the data is really sensitive, especially PII data, personally identifiable information. So it become hard. Now today we have to start with data engineering and security and monitoring and then assessment and conclusion and then we can close this as a full chapter. If anyone joined, let me ask you if you have any question in case. So nobody joined, we are good, we don't have anything. So three. So in this one, data engineering and security monitoring that we're gonna learn today is all about security, importance of security, and what are the AWS services that it provide for the security. And then we need to understand what is data monitoring and what are the software or AWS services it provide for data monitoring. And with this, we can close it and we were able to say proudly that we have basic understanding how data engineer work, who they are, and how they can leverage AWS as a service provider to accomplish the task of data engineering and why it is needed and what's the benefit. Everything we learn it. through this process. And once this is done, we will close it, and then we will move to the second section of this prerequisite module, that is data engineering AWS data lake solution. And for this one, we need a subscription for. So tomorrow, my main task, one of the tasks, gonna be to get the subscription. Let me write it down as well. Subscription for AWS data engineering category one. Come on. So we have 1.5. So I think I can take a rest because I was talking constantly. Let me check if somebody joined on my Twitch stream. Interesting. So I will take 5 minute break and then we can get started. Okay, let's take a break. You also go and have a break. I think that's fine. We can get it started with the next section. This is where, so this is the first section that we're gonna learn about the things. So let's quickly go. So today we're gonna learn about data engineering, security, and monitoring. This is really important. Security and monitoring. What is security? The importance of security in AWS data analytics workflow cannot be overstated. Any breach or compromise could lead to severe consequences, including data theft, financial loss, damage to reputation, and regulatory penalties. Security should address the following five areas. Okay. So these are the five areas that as a security we need to make a serious step. Access management, regulatory compliance, then sensitive data protection, data and network security, and data auditability. These are the five characteristics, five different parameters that we need to have a strong hold in order to ensure that our data is resiliently available in our storage without any data breach. So first one is access management. So we need to make sure that the access provided to the corresponding people who are the real people without making it available for other people. So strong access control are important to ensure only authorized user and application can access analytical resources and data with IAM, that is Identity Access Manager or Manager. Granular permission are applied on a per user or group basis using policies. And this is very interesting. Like on the user or per group basis, you can apply the policies, the rule and regulation or the access management using IAM, Identity Access Manager. I think that's the one, right? IAM full form in AWS. Yep, not interested. Identity and access management. Identity and access management. That's why it's always good to do the thorough research. So we understood that as a data engineer we need to work on two major part apart from the actual thing we are doing. This is not development route. This is more of providing the protection to the data. Two things. When you construct a building, you have a blueprint, then you have the material, then you start building, right? This is the first. That's important, right? That's data engineer would do with the data storage and data processing. But there is another aspect of this thing that is making sure that the building you're creating is resilient, is fireproof, it is like it can stand in earthquake and disaster. So if there is any disaster, it is able to handle it properly. So that's exactly what data engineer does as an add-on that is not part of actual development, but is something that is essential as a part of development, which is data security and data monitoring. So data security means to make sure that data is secure, and security can be done in five different parameters. First two, one, three, four, five. First one is access management. Okay, using IAM, identity and access management. So it says here, the importance of security in data analytics workflow cannot be overstated. Any breach or compromise could lead to severe consequences. So any breach or data gets circulated without any norm or breach any contract, there's gonna be heavy financial loss, data theft, damage to the reputation, and business losses as well. So five parameter that security should address, like it is the pointer as part of data security that you have to protect. First one is access management. You need to give access to the individual person that is actually authorized to access that data, or it is given permission from the user to access that data. So it is access management, and that you can use it, that you can perform it or implement it using AWS IAM, that is called Identity and access management. Okay. Second one is regulatory compliance. That, for example, many regulation like GDRP and HIPAA mandate that organization securely manage data and adhere to the privacy and security best practices. Non-compliance can result in heavy fines. Using managed services from AWS help automate common compliance control and auditing capacity. So regulatory compliance is like there is certain rule and regulation, the basic general rule and regulation set up by the GDRP and HIPAA that we have to follow at given point of time. And I think I should learn about them both. So in case somebody asks you as part of data security, data governance, what exactly you perform. So first one is access management. Second is regulatory compliance that we compile. We go with the compliance of a GDRP. What is GDRP and what exactly the compliance that I should be knowing and I should know as a data engineer because I am co-responsible for the data because in a big company there are different person who take care of this thing because all the modules is divided into multiple different software developer data engineers. So usually you are not responsible for this one, but you should know the end-to-end process to be a full line developer. So there are regulatory like GDRP and HIPAA that constantly release the policy about how data should be gathered, how data should be governed, how data should flow, what kind of a data should be flow, what cannot be flowed, how it should be visible, how not it should be visible. So this check has to be always checked properly before it is released and be available for the people for consumption. Third one is sensitive data protection. So data analytic of so this is part of compliance only, but how you handle it, that's something we need to understand. Sensitive data protection. Data analytics often involve large volume of sensitive data such as PII, personally identifiable information, financial record, or health records. This must be protected from unauthorized access, theft, and leakage. AWS Security provides services like encryption, masking, and identity and access management, data loss prevention for security. So, second thing, because this is part of regulatory, dude, regulatory. All it says you have to follow regularity, and the third part is also the third point is also the part of this one, but it does says specifically. So in case you don't know it, you should understand this is important. That is your sensitive data and sensitive data protection. So if there is sensitive data in your storage, for example PII, personally identifiable information, or financial data or health data, we need to make sure that this data is not, even if it's accessible, it should not be visible to anyone unless you have the proper authority to access this one. So for this one, AWS provide different services like encryption, masking, and uh, then again IAM is also there, right? Identity and access management. Based on this one, you can manage the group of people those can access it. That is data and network security. Simply, if your data is available in the network, you need to make sure the data is not being able that system is not hacked by anyone. Unauthorized forceful access of the data. AWS like security group network control access list and firewall help restrict network access and secure the computer store. So simply somebody sent you a spam mail, what happened? You click it, your entire system got accessed by other person, then he can do anything on your system. So what is it? It is a network breach, not a database, network breach. Then he will access your data set and then take it and make it available or publicly or use it to threaten you. This is data breach. So you need to understand there is no data breach or data security or data and network security, network security. Okay. So fourth one is you need to make sure there is a huge security on the network. So network security, so the firewall is not breached or a hacked, your system not get hacked easily. Data auditing, this is something I need to know. It is essential to be able to track the origin, transformation flow. Okay, so this is beautiful. I think I now understand data auditability or data audit or data auditability. So what is audit? Audit is to make sure whatever happened in your data is traceable, it is legal and traceable. So we are not concerned with this one, but we are more into traceable. So data auditability or data audit means the process of being able to track your entire data flow journey from data source till the processing is called data uh, auditing. And this is something is since this is something I told you, that when the data is dropped into your system, there's one thing that is start working, that is AWS crawler get the metadata and store into a catalog. So catalog is nothing but the information about the data or a collection of metadata. So metadata itself hold all the information like who is the owner, when it's dropped, when it was inserted, when it was updated, what's the format of the file, what's the inside the file, where is it, what's the name, what's the extension, everything. So this auditing can be done using AWS Glue catalog. Plus AWS provide. Okay. So data security, again, I told you data security means to secure data from multiple streams. Okay. So make your data secure so that it is not breached. Any of the contract is not breached, so that you can avoid heavy financial losses or reputation losses. And this data security, to secure your data, you can do it into 5-step process. First one is access management. You give the access to the right person with the right uh, authentication. Okay, so access management, that you can use it IAM, identity and access management. Second thing you can do is to follow the compliance of GDRP. So it's called regulatory compliance. That everything that you do from data processing, data hiding, masking, everything, it as per the standard of GDRP, so that the minimum level of data security or governance, data governance, between not security, but data governance can be followed properly in order to increase the data security. Third one is sensitive data. In case you have a sensitive data, because it's part of GDRP, it says that if you have a sensitive data, it cannot be publicly available. For example, PII, that is personally identifiable information, health records, or financial record. This kind of a things that should not be publicly available. So AWS provide you encryption, masking, and then you can use again IAM to provide access to the right person only. Then the fourth one is your network security to avoid any hacking or unauthorized access. And the last one is data auditing. That means to be able to trace the entire journey of data flow from where it began and where it has gone, and who was the owner, who made the change, when they made a change. So this entire history is maintained into the catalog of AWS. And who does it? AWS crawler. That's the security. Let's see what X it has to offer us. So AWS security following is a partial list. So there is a huge list of AWS services based on the platform, based on the need, based on the scenario. But the majorly uh, the major security access management services that people use. First one is IAM, that is identity and access management that we talk about. So this is a service that enable you to create individual level of policies. When I say policy, let me tell you. Like for example, let me show you here. Okay, this is AWS, and there's one service like S3, and in the S3 there is one folder. Suppose HTTPSX, whatever it is, then HTTP, then CD, and then the file name dot .xl. Okay, and what happened? I am an individual person. Then there is another A, B, and then C, and then I created a group that's empty right now, and a group name I call it CD file permission. Okay, so I go to the admin, like who is the admin, who have the entire access to this AWS container that is specific to our company called XYZ, right? So he is the admin, right? Admin, he have all the privileges. So I go to him that I said that ABC need access to this one, this place, right? And everyone should have the read access, but only I should have a write access. Okay. So what it does, firstly, he created a group called CD, okay, read permission. And in this group, he put everyone, okay, A, B, C. Then for your individual access. He gave you the right access as well. So now when B goes, he will access through this group, because in this group he's attached to this group, right? So individually he have that access of read. He automatically go and read it. But when she or he try to write it, it will throw an error. When this guy goes in and try to read it from this particular group, being part of this group, he have the access. So he will check in the privilege log that does he have an access. He will see is the part of this group called cd file, and it have the read access. So he will allow it. Okay, so he can read it. But he will try to write it, it will throw an error, because in this group there's only read access. But this guy, when he goes, he read it, he saw is part of this group, he will allow the read. But when he will go and write, he saw that for writing, this guy have the permission, so it will allow writing. So now what you're doing, you are segregating the access management permission of privilege based on this policy, and this policy is created in a software or service called IAM, that is Identity and Access Management. I think we are very clear on this, all right? Then second one is AWS Certificate Manager. What is it? Use ACM to provision, manage, and deploy SSLS and TLS certificate for AWS services and application. Okay, this is human level. Second one is to access the site level. You need that client server access the connection, right? For this one, you need to create this SSL and TLS certificate. If not, you don't have the permission to interact with AWS services outside the AWS. So what happened? Sometimes the AWS is here, but you are here. You might not have direct access to a particular this one AWS as account and here. What you do that you will allow the access, okay, without using AWS software through some CLI, and you can simply put your name, your what we say credential, and then to create this pipeline you need a certification that he is certified to create this pipeline to ingest. If not, anyone can simply go in and started misusing this, get access inside the system. That is basically hacking. So to allow this access inside one, you need a certification that it is bona fide certified that he is a member of this one. But instead of using AWS as a service, he is using CLI or a command based prompt interface to simply access to AWS. This one, for this one, they need certified manager, because SSL and TLS certificate is required to establish this one. That's why this is called AWS Certificate Manager. Now move to regulatory compliance. So I told you that for regulatory compliance, we need to follow GDRP or HIPAA, right? So either you can create a list in your pen or paper or Excel and then start taking. But for this one, they also created a virtual a software that have that checklist. We simply go and do the things. How it is done, I'm not sure, but we're gonna learn. So this is called Audit Manager. So it will automatically collect and organize relevant evidence from AWS services and translate it into auditor-friendly report in standard like GDRP, PCCI, and others. So it automatically create that file where it shows that what data is coming and how you are following the compliance and is it right or not. How much compliance is done, what we are doing. So in this tomorrow somebody asks why it failed, you can tell that we are following all those steps. This is something new and we were not aware of this one, and we are working on this one. And AWS will get into this one as well, because that he need to did this one, because we get these services because we thought that this gonna be 100% secure, right? That's why we paid for this one. Then AWS config, that is provide configuration management and auditing of AWS resources to access security and compliance posture over time. So you remember there was a time that we tried to store our username and password for automatic access into key, right? So configuration is same. It's like a JSON file where you put key and value, and then you can simply access it anytime directly using IAM, and then you can get the credentials, and then you can log into another system. So it bypass that. It's like a storage management. I think that's the same thing happening nowadays. When you try to type a new password, Google automatically store in the manager, right? This is AWS config, if I'm not wrong. I need to see. So AWS Config provide configurationable management and auditing of AWS resources to access security and compliance posture over the time. See, here it store your password and everything. That's something you see in your computer laptop nowadays, right? When you create a new password or profile for a new website, Google automatically asks that do you want to store it into this one? So that storage is nothing but AWS config. So this two is done. First one is done for access management. Second is regulatory compliance. These are the services. Third is sensitive data protection. So sensitive data, you simply put that masking, right? You can do is through AWS Glue job that protect this one. You can simply use encryption using AWS KMS and data masking. And again, it's the same thing. AWS KMS uh, that is key management service. So what key management service do? It identify the keys or the key that we provide and it encrypt that key, and then we can decrypt it based on our uh, need or requirement. Mackie uses machine learning and pattern matching to discover and help protect your sensitive data, such as this one. So it scan through your data based on its previous learning of the model. It understand which is your sensitive data in case you don't have that information, and the data size is so big and you don't understand, because there's a lot of time when you people are working or the people who are not well aware of this one, so it become literally hard for them to understand which one is PII data, which is not, and sometimes they might miss out and it may lead to a huge problem. So avoid human error. AWS provide a service called Amazon Mackie that run on machine learning that is trained to identify any record that is PII, and it give the information and then suggests that we need to do masking before making it available for any other person to consume. Second one is you can do that masking manually using AWS. You can simply so this is the one it identify, then you can use AWS KMS, that is key management service to lock. So key management service like manage the keys to simply lock the PII data or sensitive data and lock into a paper box like encryption and then get the key. So that's why it's called key management service. And again, you can do this one using AWS Glue, where you can simply call these services and do that same on your data. Now, data and network security. Data security and network security is like creating a firewall strong enough that is not breached with unauthorized access. So you can use it AWS Control Tower, AWS Guard Duty, AWS WAF. So AWS Control Tower, you can set up and operate your multiple account AWS environment with a prescriptive control. Okay, Guard Duty provide a threat detection service to identify potential security issues by monitoring AWS resources like network application and this one. So, so see how how the fortification work. There is always a tower, right? Which keep an eye on everything. So that is AWS tower. Then when that tower is done, second thing is in the gate there is a guard that protect the gate, and something happen it will automatically trigger the alarm, right? So that guard duty does it always stand in the application and see if there is anything wrong with the application or any system or potential threat. It will automatically alert the people. That's why it's guard duty, to alert the people. Control duty is like to have overall watch on the infrastructure, that if something is wrong it will trigger. So it will look at your account, it will look outside the account, and then AWS WAF to protect a web application from common exploit attack, protect application and availability. So I really don't know what's the major difference, because this is something part of security, data security or cyber security. So I'm not sure in that. We might get into this one as part of data engineering, but I think this is more towards the uh, cybersecurity rather than data engineering. But we should know that's a good thing, that this is the application, we will do it, and I think we should learn it, because since data is our ownership, we should make sure the data is secured properly. Then we have provide a distributed denial of service migration service to protect application running on AWS from wall metric attack. What does that mean? Shield. Provide a distributed denial of services, mitigation, service to provide to protect application using on AWS from volumic. I'm not sure, dude. I never heard of this one, so that's something we're gonna learn. Okay, we got to know that there is a tower, then the guard duty, then WAF, and then says shield, right? Let's see what is data auditing. We already talked about this. Is gonna be AWS data catalog that does everything. There's two more, that is AWS CloudTrail and AWS Lake Formation. What is CloudTrail? Provide auditing and logging of API calls. So based on different services, there is different auditing. So like if somebody is trying to access through API calls or CLI calls, that we get the certification, right? SSL and TLSL certification through APIs, right? Or client uh command this one CLI, right? So this is something it does because it automatically send it to here that comes link, right? It send messages. So CloudTrail is the one that is responsible for data auditing. Now lake formation, I think this is quite so in a couple of days I am constantly watching for the job, right? So lake formation is something that I see often nowadays. So lake formation automatically catalog the source and destination of the data in AWS Glue data catalog. This provide metadata about origin, landing, location, and transformation of data. So what data formation does, it catalog the source and destination of the data in the AWS data catalog. This provide metadata about origin, where it come from, where it landed, and where it goes after transformation. So the entire journey is done by lake formation, and catalog is where all the catalog is provided. Okay, so if you remember, AWS crawler get that information, but if you need to understand the see, catalog give you metadata about the free data, but who is the owner, where it come from, where it landed, where it goes. That sequential, the entire end-to-end flow. Okay, I'm not talking about the metadata about the data. It is metadata about the workflow or the data flow. So the metadata of the work the data flow, the metadata of data flow is done by lake formation, and this is beautiful, dude. So remember, if AWS data is being manipulated using API, then we have CloudTrail, right? Now, if data is coming from this source is landed here, then is process landed here, and then ultimately goes this one, right? So this metadata of this entire journey is being procured by AWS Lake Formation. And the metadata about the data, like what kind of a data is it, where it is stored, where it was ingested, everything, that metadata information is called metadata. Okay, so this is done by lake formation. When you get the metadata about the data flow is lake formation, and the metadata about the data itself, which is done by AWS crawler, and everything goes into AWS Glue catalog. So let's check if our understanding is to the point. Now, security best practices. So as data move between different data storage, like is this, and AWS Glue track this location change metadata in this AWS catalog. This enable the trace of the data flow. Right. That's done. That's pretty much the same thing. So create IAM and policies to control the data access. Use AWS key management service to encrypt the data, and this thing. Use data masking to avoid the data visibility of sensitive data, PII data, or health data, or record data. Network isolation, simply use virtual key so that your network is not accessed at any given point of time or directly get access into your system. So use VPC, virtual private cloud, or virtual private network, virtual private cloud. Understand applicable laws, that what laws should be followed properly, classify data, create a classes of the database on sensitive. Yeah, that's true. Like, if data is coming, you need to make sure that you simply don't dump everything. You understand the nature of the data, and a sensitivity, and then you created different directories, and based on the directory you created the level of data security or network security over that one, so you are safe at any given point of time. And to identify this one, AWS has again a Mackie, I think there is one machine learning algorithm that does that. Plan for disaster recovery. Yeah. If anything happen, you have to. I think AWS has all this thing. We don't have to worry of this one, data recovery. Define and implement data governance. That's the problem with this one. So if a data goes into cloud, remains in the cloud, no matter what you do. Even you delete everything, I think they can trace it back. Tough for data. Define and implement data governance. Yeah. So data governance is like design comprehensive, flexible, and robust governance security and technique. So this is something we need to learn more as we progress, but it was interesting. Interesting. Let's take 5 minutes break. Then we will go to the monitoring part, and it's the same as that what we did for this one. And then we will close it today, and most probably tomorrow we need to do again the revision, especially this one. I think I won't be doing top one. I will be focus on more of this one, and then like tomorrow we will on the first part of this one. So I'm really, really, really happy that we followed through. Let me check if somebody joined and they have any question to ask. So that's okay. Let me check if my Twitch account have anyone following. No. So we are good. I will take a break. I will have my water and I will take a round so I can straight my back. Hi guys, I'm back. Let's get started with the third session or the final session of this particular AWS learning. That is your AWS monitoring services, right? So what is monitoring? Monitoring is a crucial for maintaining the readability, availability, and performance of AWS data analytic workflow. Okay, maintaining the reliability, availability, and performance of AWS data analytic workflow. Following are the few key aspects that should be monitored. Resources. So the entire workflow when run, it we need to monitor it, whether it is running successfully or not, how much resources is consuming, is the data is being processed properly or not. So monitoring is like to monitor the entire workflow. So in this one, there are few things that we need to monitor, that is resources. AWS resources involved in the workflow like EC2 instance, database, data storage should be monitored. Metrics such as CPU utilization, memory usage, network traffic. This I input and output can be help identify the performance and the bottleneck. Simply, how much resources is consuming to perform this end-to-end workflow. Now, analytical tool. Metric for extraction, transform and load ETL or extraction load transform ELT job should be monitored. What are the metrics? Metrics such as job runtime, error encounter, the record process, provide insight into the job performance. Ultimately, it's all about how job is performing. What is the time it is taking on average? How much resources already there, right? It is already considered. So talk about the time. We talk about the error encountered, how it handles the error problems, right? When they record ingest, so everything it look from end-to-end perspective. Then data pipeline. Service such as AWS Glue, AWS Step Function, that is, and Lambda are the commonly used to orchestrate ETL workflow. Should be monitored. Monitoring metrics indicate the pipeline health and identify bottleneck. So, like how healthy? I'm not sure what exactly healthy is, but basically to monitor if the pipeline is working properly. Yes. And analytical job metric for ETL. I think there's not much difference between these two. I need to understand what it means. Let me check what it X permission and access log should be tracked using services such as IAM and CloudTrail to help ensure data security and governance. It makes sense. What is this, dude? I want to understand this one. Where is Cloud? Uh, what is the difference between them here? Data extraction and contracts. I mean, money data pipeline and data analytics. Good clarification. This one monitoring data pipeline. This is about ensuring that data move and transfer correctly from source to destination. So focus on health of the process, job runtime, error counter, all this one. Data analytics. This is about data itself is correct and usable for. Okay, that's why I told you this is so beautiful. Okay, so first one is resource. We try to understand how much my our job is taking resource like CPU consumption, our storage, our input and output network traffic is to instances, database, everything. Second one is the data itself, data analytics job. Whether the data that is processed through our pipeline ETL process is it healthy enough for our data ingestion? Is it corrupted or not? Well, we just need to monitor. Third one, we need to monitor data pipeline whether it runs successfully. Was the job time, was the average job time? It is error prone, how it handle the error, how it is able to access. Okay, so everything about it. Now the third aspect we need to talk about the access management, whether the access is properly managed to the right person, right thing, right. So monitoring, we need to focus on four things: what resources we are using, whether the data that is processed through Is process healthy? It is right, non-corrupt. When the data pipeline who's going to process this data, is it healthy? It is processing properly without any issue or everything. The fourth and the last one is again monitoring of your data access or access management. So first one is resource, how resource is consumed. Second one is data is correct or not. Third one is data uh, pipeline, whether the pipeline is working properly or not, and then the access given to this one is right or wrong. So RDPA, something like this. Okay, resource consumption, our data correctness, then the pipeline, RDPA, then pipeline health, or job time, or all this, and access management. These are the four that we need to keep in mind at a given point of time. Now, for all these four, there are different services that AWS definitely provide. If you remember, there was the Watchtower or CloudTrail, right? Now we have CloudWatch. Dude, there's too much. CloudTrail, we know that it keep track of API calls and the movement or the corresponding action performed on this tree. Right. So AWS monitoring services. So CloudWatch, there was one CloudWatch that keep an eye on your infrastructure, whether infrastructure is correct or there's some problem. Then there was guard duty that keep on guarding your infrastructure. If it find any kind of miscellaneous activity or something that's bit problematic, it will raise it. You can set up and operate your multiple account AWS environment with prescriptive control. So it's like a watchtower. It control your entire houses, whether the houses are secure properly or everything. Then guard duty is just to guard the entire system from outside. This is from inside, this is from outside. WAF, I'm not sure. We will learn it, I think. Now that was watchtower, there is CloudWatch, then CloudTrail. What is CloudWatch? Collect metric from AWS resources like EC2 instance database and data pipeline. You can set an alarm and visually puff. Okay. So it's like a visual tool that gives you the end-to-end understanding of the resource consumption and everything. CrowdTrail, it gives the track of the data movement and the action performed when the API call is being made. Then X-Ray, it provides end-to-end monitoring and performance insight for applications running on AWS with the underlying services. So this is, see, simple. CloudWatch is like modular based. This is end to end. When the service is started till the end orchestration. Okay. This is individual based. This is end to end based. Like completely averaging or something like how application is working end to end, right? Then guard duty again, it detect any potential issue like any threat on your workload monitoring, any malicious behavior, something. Then system manager. There was IEM that I know. Then was ACM, that certified manager. AWS certificate management, ACM, yeah. And the third one is this system manager. There's too many services, too many services based on your requirement. uh, Charge you to. They want to charge as much as want. They create a software. They have infrastructure and like we name it, we have it. You just ask us to run and we will run it. So system management, it does provide application level monitoring for EC2 instances and help automate and operate tasks. Provide application level of monitoring for E2 instance. Then what's the difference between this and this? So collect the metrics, provide application level of monitoring for it directly run on EC2? Not sure. Maybe like it collect the logs, it directly run on the system and see how to manage this A to C2. I don't know, dude. We do. I think that's how it is, maybe. Not sure, look. I'm not sure. Like I never use it. I will use it, definitely. I will use each and everything. Even if I have to put the money from my pocket, I will use it. Now, monitoring best practices. So, for security, we already, as per the classification, there is a corresponding good method that everyone should follow. Similarly, for AWS monitoring, there is a best practice for the corresponding classification, the four classification we done: resource, then data, then pipeline, and then the access management. So now AWS compile best practice by studying the usual pattern and experience of thousands of customers for more than a decade. See decade. Test and validate analytic job. Test development before making change in the production. So you have to, this is the basic, you have to test your job before you even move to production, then monitor key metric at each stage. So there's two, you don't have to look at the end to end. That's good. Ultimately, you pay for the entire, right? But you should also maintain at the individual modular level, because that's where you understand which particular module is taking much more time, and you can understand that the process might be giving the right answer, but the way process is done might be not optimized. And then based on this modular level of metric, uh, investigation will enable you that for which module you have to work on optimization. Set up alert for critical failure. Again, if it failed, just send a notification, and then you need to have a backup plan that in case something goes back, you need to roll back. So notification and the rollback plan or data recovery plan. Integrate monitoring and visualizing tool like QuickSet. Ultimately, it gives you end-to-end workflow. There's one more that I checked right now here. A CloudWatch that give you instant, and X-ray that give you complete end-to-end. But then there is another is managed when Grafana. See, it's just how it provide other software as a service that's not built by them. So they write managed, so simply they can use it. QuickSight is there, I guess. That's why they don't use it manage, I guess. Not sure. Integrate monitoring and with visualizing too. So simply it's a dashboard based on your workflow. It integrates with the workflow, give you the modular level and the end-to-end level of insight through beautiful visuals. For example, your pipeline was like this, and it was put on your step function, and it include lambda functions, right? And you're running it. So you can use a software as a service that get attached to this one, and every stage it try to access them. So when you click this one, for this one there's an icon, you click it, it will give you all this like graphs, like how the CPU is working, how this one was the diagram. So it's easy to understand. And when you click on this one, the same thing happen. When you click end to end, it will give you end to end picture, like what the your resource usage, what's your storage usage, then your health, runtime, everything, like compare with the last time, everything. So it make you understand how optimize your job is end to end based on these matrices. So give you an understanding of how optimized it is, how optimized it is not. And this will also give you an understanding how much money you're gonna pay. The rough idea. So if your data is taking a lot of time, that means you need to know which one is taking a lot of time. Then you can use it to watch a cloud watch, simply understand individual hardware level. Then you can optimize it, reduce the time. Then again see the end to end. When it is reduced, and you're like, okay, this is okay. This is this much I was ready to pay, or even if it's less than what I was initially thinking, so we are good. You can again optimize it, but once it is optimized, is less than your budget, people don't touch it because they feel like they might break it. There's always golden rule. If it is working, don't touch it. And especially when it is under the budget and optimized, don't touch it. Periodical review matrix. So again, same thing. You have to periodically check your performance and see if something can better can be done. Now quickly look at this one. What typical consideration for securing data in AWS analytical environment? Okay, three I need to check. But what are they considered as securing? Secure data security. Implementing least now. Encrypting data at rest and transit to protect can be validating regular backup and performance now. Monitoring infrastructure for the change in user activity with the alert and abnormal activity that is done by guard duty. Creating dashboard to visualize, analyze results to extract insight. Now this is monitoring. Building and automating scaling of computer resources to meet the infrastructure demand. No, that is auto scaling that is done by AWS using a serverless server. Implementing least privilege access and preventing unintended access to the analytical infrastructure and data. That's true. So that's the three that I feel like. Right? I was right. What are the recommended monitoring best practices? Three. Recommended best monitoring. Optimize the storage cost by no. There is optimize the storage cost. That's something part of optimization. So what are the recommended monitoring best practices? We need to give the best practices, not the what can be done to improve our. That's like a byproduct. Test and validate job. That's true. Uh, Optimize the storage cost by using appropriate no. Restrict access to log to data scientists only now. Integrate monitoring and with visualizing tool. Yep, it increase the high understanding of the workflow with the least amount of time investment. Set up alert for critical failure. Yep. Use AWS function or no. That's something different. Down now again, which option are areas or activity or data analytics system that should be monitored? We need to monitor this one. So job submission completion time for the batch processing service like this one. It can be areas or activity of the data analytics system that should be monitored. So job submission and the completion, we need to see whether it is done properly. Storage naming no. Internal email log calendar now. Resources utilization of yes. We need to understand how. So ultimately, monitoring means to understand if the data is flowing properly or not. Right? Be it resource, be it data, be it pipeline, or be it access management. Right? This four parameter we monitor through this one. It is just to increase the optimization and reduce the time. This one so that the resource can be diminished, usage can be diminished, and our overall expenditure can also be diminished. That means our chances of increasing profitability goes up, or the extra fund can be used for extra development. Application performance metric like request latency, error rate using this CloudWatch. Yep. Okay. Now, which metric would be useful to monitor when analyzing the performance of which metric? ETL job running on Glue. So submission time, like completion time, than the usage value. So there's a worker resources like CPU, it can be ETL job duration 100%. Inventory level of physical server no. Number of open support cases no. ETL failure and retry rate and data storage no. That's the one. So am I going to start this one? I can, but I'm not because tomorrow again I have to come and do one quick revision on this one and all this, and then I will take the exam. So tomorrow for three set of this one, first two will be revision completely, and the last one will be assessment. And tomorrow we will say finally a farewell goodbye to the foundation rule and concept under data engineering on AWS. A prerequisite course for AWS Data Engineer Category 1 examination course. My God, it took like 6 to 7 days a week for this one. This is very, 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 very like I have to run. Yeah, I think that will be much faster. And tomorrow as well, I need to do the subscription thing as well. So everything, everything, everything. So before I close this, anyone join and they have any question they want to follow up on this, let me know. Nope, we are good. Okay, so I think I can get it close. I still have 5 minutes, I think, but I can add that to my. That's fine. So with this, I will just close it.